Good morning, all. Today we discuss demodulation of a modulated wave. We know that in a modulated wave, it may be frequency modulated or amplitude modulated. The modulated wave contains the informations about the signal and also the carrier signal. But we need only the signal part. So we have to separate the carrier signal or the carrier wave from the modulated wave. That process is known as demodulation. So in a radio receiver, it accepts the modulated signal through its antenna, and that signal is amplified and the carrier is removed. This is done in the radio receiver. This is called demodulation. Look at the block diagram. The signal of the signal from all the transmitting stations is available to the radio receiver that is in touch with the aerial from a particular station should be selected. That is done with station selector, and after that we get only the signal from that station in the amplitude modulator or in phase modulated format. To obtain the program from that station, we have to demodulate that signal. That circuit diagram is known as demodulation circuit, and the demodulated wave contains only the sound wave or the modulating signal that is amplified and it is fed into loudspeaker. Then what are the essentials in a demodulation? We know that a modulated wave contains a carrier wave and the modulating signal in the two side bands. One is upper side band and the second is lower side band. So a detector circuit or a demodulation circuit perform the following two functions. When we look at this figure, it is the figure of an amplitude modulated wave. The upper part is the upper band frequency and it is the lower band frequency. Then this upper sideband and lower sideband contains the modulating signal or the our audio signal. From any half, it may be from positive or negative half, we can retain our audio signal. So to get only one half, or it may be positive half or negative half, how can we obtain that one? We can use a rectifier circuit. We know that a rectifier allows the direction of current only in one direction. Okay, then if we use a rectifier only one half, let us take the positive half, only the positive half cycle is obtained when the signal is fed into a rectifier. Look at the figure number 2. It is the figure number 2 contains only the positive half cycle, and in this positive half cycle the carrier frequency and also the audio frequency is available. We know that the carrier frequency is very high when compared with our modulating signal or the audio signal. So to remove the carrier wave, we can use a filter circuit. When we fed this signal through a appropriate filter circuit, the carrier wave is blocked and only the audio signal must be passed. So the first one is the figure first one is rectifies that signal is fed into rectifier. It rectifies the modulating signal, that is we get only the one only one half of the signal, positive half cycle, and the second function to separate the audio signal from the carrier. It is a fundamental demodulation circuit. Here, it is the receiving antenna, and this LC circuit is used as the station selector, and this diode is used as the rectifier, and this capacitor is used as the filter. Then the main components in a demodulating circuits must be a station selector and a rectifier and a filter. So the working is, we know that in the receiving antenna there must be the modulated signal from the various radio stations, and if we adjust the values of C1, the parallel tuned circuit L1 C1, it selects a particular frequency and that is fed into the diode. Here we use a crystal diode, that is D1. It acts as a rectifier. During the positive half cycle of the modulated wave, the diode conducts, while during the negative half cycle, it does not conduct. So we get this type of signal. It is the rectified current pulses. So the modulated wave contains only one half. Okay, and fed into it is fed into a filter. It bypasses the high frequency signal. We know that a capacitor has a reactance that is 1 by omega c. When the frequency is very high, its reactance must be very low. So high frequency signal, it acts as a bypass. So this capacitor bypass the high frequency signal. So only the audio signal, that is low frequency signal, is fed into the speaker. if we connect the diode direct into the speaker, we can't hear nothing because the signal, the signal from diode contains the audio signal and also the carrier signal. The frequency of the carrier signal is very high, so we can't hear nothing due to the inertia of the speaker diaphragm. That is, the diaphragm of this speaker is vibrating, but when we know that the frequency is very high, so the vibrations performed in a second must be very greater. So the diaphragm of the speaker can't perform that vibration. This is the fundamental diagram of a detector. It is also known as diode detector. Now we go to the details of radio receiver using for amplitude modulated wave. What is a radio receiver? Is it familiar? Nowadays, different radio receivers available, that is AM and FM. In our syllabus, we have to discuss only the amplitude modulated radio receivers. In India, amplitude modulation is used for radio transmission and reception. There are two types of amplitude modulated radio receivers. We discuss that in following sessions. To reproduce a sound wave from a AM modulated signal, a radio receiver must perform the following functions. First part is the receiving aerial must intercept a portion of the passing radio waves. We know that the signal radio signals from various stations is interacting with radio receiving antenna, and such a antenna is get only a fraction of the signal transmitted from the radio station. So we have to select a particular radio station, that is done with LC circuit, tuned LC circuit that we discussed in the previous slide. So that LC circuit, tuned parallel LC circuit, select only that radio frequency which is in resonance with them. We know that a parallel LC circuit or series LC circuit must have a resonance frequency. So the frequency matching to the resonance frequency is selected for that radio station. Okay, then a particular station is selected, and then what we have to do? We have to amplify that frequency, radio frequency, by using a tuned frequency amplifier. The importance of tuned frequency amplifier is, we know that the amplifiers has, the audio amplifier has a flat response, frequency response, and in some amplifiers, how we have discussed in multi-stage amplifiers, that is when we using a transformed coupled amplifier, for a particular frequency it must have high gain. Such amplifiers are known as tuned frequency amplifier. So for the particular radio frequency, this amplifier must have very high gain. Such amplifiers are used to amplify the radio signal. Then from that amplified signal, we recover the audio signal. It is done with a demodulating circuit. Okay. Then using the demodulation circuit, we can obtain the audio signal from the radio wave, and the audio signal is further amplified using audio amplifiers, and the amplified audio signal is fed into speaker for sound reproduction. This is the main functions of AM radio receiver. Then types of AM radio receivers. There are mainly two types. First one is straight radio receiver, and the second is super heterodyne radio receiver. In the beginning of radio transmissions and receiving, we use the straight radio receiver. It has some disadvantages. So nowadays we use these super heterodyne receivers. It has many advantages when compared with the straight radio receiver. We discuss the straight radio receiver first. This is a simple demodulation circuit. Look at the figure. A receiving aerial, an RF amplifier with a parallel LC circuit and a detector, and AF amplifier, audio frequency amplifier, and a loudspeaker. Its operation is similar to that we discussed earlier. So the aerial is receiving the radio waves from different broadcasting stations, and the desired radio wave is selected by the RF amplifier, which employs a tuned parallel LC circuit, and this amplifier select a particular radio frequency, and also it amplify the radio signal, and the amplified radio wave is fed into the detector. Detector is used to demodulate the audio signal from the radio signal. So detector extract the audio signal from the radio wave, and that signal is amplified using audio amplifiers. The amplified audio signal is fed to the speaker for sound reproduction. It is the functioning of a straight radio receiver. Next is the super heterodyne receiver. Before going to super heterodyne, just mention the difficulties associated with straight radio receiver. The main difficulty is the use of RF amplifier. We know that this RF amplifier has a variable capacity. We know that these RF amplifiers has they are tuned RF amplifiers, because for a particular tuning frequency or particular resonance frequency, it must have very high gain. So when we using this RF amplifier, that particular RF amplifier has high gain for a particular frequency. Okay, when we changing the quantity, that is when we changing the value of capacitance here, only the selection of radio wave is changing. It will not change the frequency of that amplifier when it has very high gain. That is, a tuned RF amplifier must have a particular frequency. For that frequency, it will give a very high gain. For other frequencies, the gain must be very low. The tuned RF amplifier must have a sharp frequency curve. So, when different radio stations is tuned using such radio receivers, they can't give us a good audio signal. A particular station must have a very good audio signal, and the other radio stations can't be tuned very well using such a receiver. This limitation is overcome using the super heterodyne receiver. In this type of radio receivers, the selected radio frequency is converted to a fixed lower value or to a intermediate frequency. That is, the selected radio frequency is converted into a intermediate frequency which lies between the frequency of the radio station and the frequency of the audio signal. What will be the advantage of this? We convert all the radio audio signal this is achieved by a special circuit that is called as mixer circuit. To obtain that intermediate frequency from all the radio stations, we must use another oscillating circuit. This oscillator produces a high frequency wave that must be greater than the radio signal frequency. In such a way that the difference between this high frequency wave and the radio signal wave must be equal to the intermediate frequency. It is done with the mixer circuit. In the mixing process, beats are produced and the mixer produces a frequency equal to the difference between the local oscillator and the radio frequency. That particular frequency is the intermediate frequency. That intermediate frequency is 455 kilohertz. That intermediate frequency is 455 kilohertz, which means when a radio station has a frequency of 600 kilohertz, the oscillator will produce, the local oscillator will produce a frequency of 1055. Then the difference between these two frequencies, that is 1055 minus 600, gives 455 kilohertz. And to achieve such a process, we connect all the capacitors used in local oscillator and mixer and the receiver tuning is ganged to a single one, and that ganged capacitor is varying. Okay, so when we selecting a radio station having 600 kilohertz, the local frequency oscillator is set into 1055 kilohertz. Okay, so when a frequency of 610 kilohertz radio station is tuned, so for a station of 610 kilohertz, the local oscillator frequency must have 1065. When we varying that gang capacitor, it selects radio station of 610 kilohertz. In the same time, the local oscillator frequency is set to 1065 kilohertz. So the intermediate frequency must be constant at 455 kilohertz. The figure shows a super heterodyne process. It is the main factor of the super heterodyne receiver. Here the RF amplifier having a frequency of F1, it is the radio station frequency, and the local frequency of the local oscillator, it has F2, and when it is mixed using the mixer circuit, it gives F2 minus F1, that must be 455 kilohertz. So we changing only the gang capacitor, it changes the values of the various capacitors in the different circuits. As the intermediate frequency 455 kilohertz is kept constant, we can use an intermediate frequency amplifier to amplify this particular frequency. That is, we know that tuned amplifiers are used in high frequency amplifications. Then we can set an amplifier to amplify a frequency 455 kilohertz with very high gain. So such amplifier must have maximum stability and selectivity and sensitivity. Look at the figure. In figure, in the RF amplifier, there is capacitor C1, and in mixer a capacitor C2, and in oscillator capacitor C3. They are ganged to a single shaft. When we changing that ganged shaft, the capacitance of each circuit is changing in such a way that we get a mixer output of 455 kilohertz. It is a block diagram of a super heterodyne receiver. It contains RF amplifier, mixer, and oscillator. These three quantities include the super heterodyne principle, and that mixer gives an output of 455 kilohertz. It is a intermediate frequency, so we use an IF amplifier here, and this IF frequency is fed into detector, which demodulating the audio signal, and the audio signal is fed into audio amplifier and to a loudspeaker. The rotation of the common shaft simultaneously changes the capacitance of these tuned three circuits. Refer the textbook of V.K. Mehta for the working of the different stages of super heterodyne receiver. Now we stop here. Thank you.